Hello friends, a few months ago I showed you how to give your Macintosh Color Classic a huge performance upgrade by swapping out that stock painfully slow 16 MHz 68030 processor motherboard for a much faster one running at 33 MHz with a 68040 processor taken from a Macintosh LC575, also known as the coveted Mystic upgrade. After that, I released a video showing you how to recap your LC575 motherboard using super low ESR OSCON capacitors. Today, I'm going to show you the 4 keys to maximizing performance from your Macintosh Color Classic Mystic or LC575. Specifically, number 1, how to use K-Koba's Spicy O'Clock overclocker. Number 2, how to use super fast 16 nanosecond VRAM to overclock even higher. And then number 3, I'm going to show you the importance of capacitors on the motherboard, which will help you reach the absolute maximum overclocking speeds. And lastly, number 4, I'm going to show you how to swap out the LC68040 processor for a faster one that has onboard FPU. K-Koba is owner of Karo's Mac Mods, located in Tokyo, Japan. His store offers a variety of interesting, low-cost, and highly useful items for vintage Macs. In October 2021, K-Koba released his first Spicy O'Clock prototype. Kay designed the schematic and showed it to Stephen Arsenault of Better Bit. Stephen created the PCB and then worked with K-Koba to create at least one revision and finally came out with a shipping product. To install Spicy O'Clock, you'll need at least 3 wires, so I recommend paying the $2 extra to get the optional 4 jumper cables on Kay's product page. Next, you'll need a soldering iron and solder. You'll then need a way to mount Spicy O'Clock to your motherboard so that the solder pads don't short anything. You could use hot glue for that purpose, but I think a small piece of Velcro might be better. And lastly, while not required, I found it extremely fun and helpful to buy a cheap frequency counter kit and related items on Amazon to very precisely see what your chosen clock frequency is. As of the making of this video, Spicy O'Clock is compatible with the LC475, the LC575, also known as the Mystic when used inside a Color Classic, the Performa 588, LC630, Quadra and Centris 650, the Pioneer MPX-LX100, which was a Macintosh clone sold in Japan, the Quadra 800, and the Quadra 840 AV. Basically, Spicy O'Clock can be used with any Macintosh that has a 68040 processor and one of the following clock driver chips on the motherboard: the XC88916DW, or the MC version of that same chip, or the 343S1108. Now with that out of the way, let's get started. While not required to use Spicy O'Clock, K-Koba recommended this very low-cost frequency counter kit, which can be connected and used even when the Color Classic is running to accurately display the chosen frequency on Spicy on this 7-segment LED display. And here's the kit I got from Amazon with absolutely no documentation whatsoever. I've put links for you in the text description below, one of which is to a schematic and the other explains how the push-button menus work. Putting the circuit board together wasn't too difficult because I just followed the silkscreen markings to know where to put the components on, and basically it just boils down to your soldering skills. And here is the finished board. Note that it came with all of the parts that you see here except for this 4-pin header here, above which you can see it's silkscreened minus, plus, in, and then G. I cut off 4 pins from one of the little headers that I have in my header kit here. I introduced this header kit in my Raminator video. You can buy them very cheaply on Amazon. And then I also have a wire kit, which will allow me to very easily connect wires to the header. I then used my plastic spacer kit to add 4 feet to the bottom of the circuit board to keep the board suspended off of my desk, because I also added 2 wires on the bottom of the board right here because the AC adapter I wanted to use with it didn't have a matching connector. This is quite small and a little bit non-standard. This is just an old adapter I had from my AC adapter stock. I mean, if you're like me, you have plenty of old unused AC adapters that still work. So what I did was cut off its connector, and then I soldered on 2 female connector leads from my wire kit, and I put some heat shrink tubing over that part so that I can then connect them to their matching connectors over here, making it very easy to disconnect the AC adapter without having a connector like this. Now when I plug in the AC adapter, all the LEDs light up and then I get a 0 here, but it's very difficult to see the LED display. Ever the true friend though, Keikoba very kindly sent me a polarizing film here that makes it much easier to see. Using 3 wires with female connectors from my wire kit, testing Spicy O'Clock is quite easy because of this 4-pin header here. I connected a black wire from Spicy's ground pin over here to the G pin over here, which is ground. Then connected a white wire from the output of Spicy over here to the pin marked IN over here. And lastly, I connected a red wire from plus 5 volt VN on Spicy to this left side of this resistor because I found that there is 5 volts here that comes directly out of this regulator. Now I disconnected the power wire for now while I turn on the power for the frequency counter. And note that it says 0, but it's best if we zero this out before we start testing the Spicy. And to do that, if we push the button here, it'll do a menu of quit. And we want to go until it says 0. 2ERO means 0. And we press and hold, and it flashes, and it's now zeroed out. So then what we can do is connect the power wire to Spicy, and we see that with the jumper in the middle setting, we're getting 19.006 megahertz. And if I take out the jumper and then place it on the far right, we're getting 17.3645 approximately, and 17.365 times 2 is 34.73 megahertz. So in the lowest setting, with the jumper over here on the right, and with the potentiometer turned all the way down, which is what it is now, then you would be able to run the output at 34.73 megahertz. Now that is the CPU clock speed, but the actual output of Spicy is what you see here on the display, and that's because this will be multiplied by 2 on the motherboard, which I will explain later. So if we take it out again and put it back in the middle, we can then take a tool and then twist the, now because it's minimized, we can't go lower, but we can go higher. I'm twisting counterclockwise right now. And you can see it's slowly going up, very slowly. And this is very nice because it will let you fine-tune Spicy. So you can see it's 19.36775. So if I want to just go up just a little bit more, just a very little twist, see? It did 0.001 up. A little bit more. See? You can refine it even to this digit over here, which is pretty neat. Now because I know, after talking to Keikoba and doing some extensive testing already myself, using the prototype, that pretty much any CPU is going to be able to do 40 megahertz, I might as well up the output to 20. And there we go. So again, this will be multiplied by 2, so it will be 40 megahertz at the CPU side. To do the installation, we need to figure out, are we going to connect connectors to the header pins, or are we going to solder wires? I am going to solder the wires because I want to use these header pins to have temporary wires that will go outside the case to my frequency counter. And by using the header pins, when I'm finished doing the clock adjustments, I can then just very easily remove them. And here is our motherboard removed and placed on an anti-static mat. You'll note that in this location is where we're going to install Spicy O'Clock. Normally the stock battery 4.5 volt Rayovac is installed here with Velcro, but all of them have long since died. So what I did is I removed mine and purchased a little 3 button cell battery kit from Amazon. 1.5 volts times 3 gives 4.5 volts. I just clipped off the leads from the old battery and soldered it onto this. I'll put a link in the text description below for all of the things I'm talking about on Amazon in this video. And the benefit of putting the battery over here instead of here is you'll be able to put Spicy O'Clock much closer to the points that we're going to solder, keeping the wires shorter, which will ensure better noise immunity. And also note that before we get started, we want to remove the RAM SIM and also the VRAM SIMs. Removing of these SIMs isn't required, but it's actually just a good idea so you don't accidentally bump or break them while you're working in this area. You'll also note that all of these capacitors are new. I used OSCON very low ESR capacitors to recap this board. Please see my video on that. And there is good reason why you should use these capacitors on an LC575 motherboard instead of solid tantalum and even instead of polymer tantalum, which I will explain later in this video. Now, because I want to affix Spicy to this Velcro sheet here where the battery normally goes, I'm going to affix this fuzzy side Velcro sheet to the bottom of Spicy. Now, as you can see, he's got some through-hole pins here. He's not perfectly flat, which means this guy isn't going to stick so well, and I may ultimately need to use some hot glue to secure it, but for now, I'm just going to affix him to the bottom the best I can. And it's pretty sticky, so it might do the job just fine. And we'll mount him just like so. And he wiggles a little bit, but he's pretty secure. Now our first connection goes from Spicy's output through this yellow wire to what is perhaps the most difficult soldering point, which is to this XC889116DW55. You might have a DW70. The 70 and the DW80 are actually faster chips than this, but as you'll see in my overclocking, I am able to overclock to some extremely high speeds, even with this slower 55 edition chip. But basically, it is pin number 8 over here, and because I've already been testing the prototype for a number of months, I already have that pin desoldered. You can see the teensy tiny pad down here. It's free of this pin. So I had to apply heat and then a little bit of leverage by putting a pin underneath it and pulling up on it. Now, I pulled up on it to make it perfectly even with the top. I didn't pull it straight up because of metal fatigue. You don't want to break off this pin. If you do, you're going to have a problem. You can probably still buy these chips or something similar now, but I would suggest you don't break it off. Just pull it up a little bit, just enough to separate it from the pad. And you want to make sure your wire only gets soldered to that pin and not to any of the adjacent ones. Next, we need 5 volts in ground, and the best place to tap those is at this chip with 5 volts being the pin here and ground being the pin here. And there we are, all finished. It's fairly easy to set Spicy O'Clock to a specific clock speed even if you don't have a frequency counter, thanks to this nifty calculator created by Stephen Arsenault. SL, LC, and HT correspond to the 3 jumper positions on Spicy, while the slider tells us the needed resistance setting on the blue potentiometer for a given CPU clock speed. So if we want a CPU clock speed of, say, 40 megahertz, we can achieve that by putting the jumper into the SL position and then using a resistance setting of approximately 1.7 kiloohm. Or we could put the jumper into the LC position and also use a setting of 1.7 kiloohm, since there is some frequency overlap between the jumper position settings. It's important to note that accuracy, or stability, of SPICY's output clock frequency will vary by resistance and temperature, which means the actual frequency will deviate somewhat from the values shown on the calculator. You will need to verify your chosen resistance on SPICY by connecting a meter, either a desktop meter like this for high precision, or your standard handheld meter set to ohms will also do the job just fine. To make it easier to connect my probes, I'm now going to take these little stubs I made from my wire kit and attach one of them to the VN header, then attach the other one to the pin marked MS. And then I can connect my probes. Right now it's saying it's set on about 1.6 kiloohms, but as we said, we want to shoot for 40 megahertz, which means 1.7 kiloohms. So I'm going to take my little plastic minus driver tool here, and I'm going to twist clockwise until I can get to 1.7 kiloohms. And there we go, that's good enough. Now with the blue potentiometer set on SPICY to drive the CPU clock speed at 40 megahertz, I'm going to show you how I'm going to make measurements from outside the Color Classics case. First, I have a wire connected to the plus 5 volt VN header on SPICY, and that leads out to my desktop voltmeter here. You don't need a fancy desktop meter like this, any voltmeter will do, but basically this is going to measure the 5 volt line on the motherboard to see if my overclocking is causing that 5 volt line to sag. And I can put the black probe on this connector output here, the little where the screw hole is on this connector will allow me to easily tap ground. Next, I have a wire from my wire kit leading from the output of SPICY, which is the frequency output, and another wire from the ground header. And both of those two wires lead out to my frequency counter, which will show me half of the clock speed of the CPU very accurately. And lastly, I want to measure the temperature of this CPU because I'm going to be overclocking it. I want to see if it's running too hot or not. And to do that, my Fluke 116 meter, thankfully, has a temperature setting on here, and it has a special wire that I can use. It's a little bit fiddly, but if I can put this wire in the center of the CPU, I can measure it actually more accurately than an infrared light temperature sensor. And I'm going to use a penny, it was suggested I try that, to press down on this, and I'm going to use some of this thermal tape to keep it secure. Now with my power cable connected and my ADB keyboard connected too, I can switch on the power and then press the power key on my keyboard to start up. Hey, we're getting 20.04, which times 2 is 40 megahertz. And we're seeing here 5.00, 4.99, and I can set my meter to give an average here, which will give me min and max values to see how much it goes up or down. And then of course this is the temperature of the CPU, which is slowly going up as it's booting. And now with it booted to the desktop, we see it has increased to 31.5, still going up slowly, degrees Celsius. And the lowest voltage I measured is 4.9997, so we're getting a very rock-solid 5 volts. I'm going to launch Norton Utilities System Info to run a benchmark in order to see how hot the CPU gets. And as system info just finished, we see it reached 53.3 degrees Celsius. Keep in mind the back panel is removed, and there is no fan blowing on the CPU. There is no heatsink on the CPU, but there is the case fan. Now this is a replacement Noctua fan. See my fan video for more details on that. And the result of today's test was a 37.0. Now, keep in mind, this is with VGA 640 by 480 resolution at 256 colors. I actually did this test with the same stock 80 nanosecond VRAM and LC040 processor, also at 40 megahertz, before I did the VGA, and I got 37.1. It makes sense that it's marginally faster because it's a lower resolution, so it takes a little bit more effort to push more pixels. By the way, I also did this at the stock 33 megahertz clock speed with the LC040, and at that clock speed it scored 30.6. So it's giving us a modest speed boost by jumping up to 40 megahertz. So now we can quit out of here and open up speedometer 4. We'll do all the tests. And after speedometer 4's tests have completed, we see it has risen to 54.4 degrees Celsius. And here are the test results. On the left, we have the test I just ran with the VGA mod, and on the right, this was with a stock 512 by 384 pixel resolution. And interestingly, the test that I ran in terms of the graphics performance, even with 640 by 480, for some reason it scored a bit higher. Most of them are 1.6 compared to 1.5 with the stock resolution, so I'm not really sure about that. But by and large, the numbers aren't too much different than the test I ran before. So we'll quit out of here, and now do Macbench 3. And here are the benchmark results. By the way, if you're wondering why it looks so beautiful, it's because I'm not filming the CRT. What I did to make it look more pretty for you is save the results, move it to my modern Mac, and I'm running this inside the Basilisk 2 emulator. Now this is Macbench version 3.0. If you're going to do your own benchmark testing, I would highly recommend you use this because version 3, unlike version 4, will run on lesser Macs like the SC30. Before I proceed, I'd like to say I'm filming this segment from home. There is some road noise. I'm going to try to filter it out to the best of my ability, but I do apologize if you hear some of it come through. Now, I ran all tests. This is the best set of tests that you can use. It takes well over an hour, and it's also why this is one of the best benchmarks out there, just because of how extensive it is. I should also say that I ran, as you can see here, 4 different benchmarks. I ran it with the stock Color Classic, which has FPU, 16 megahertz, 68030. And then I ran the stock LC575, which unfortunately says 580 here, but that's not accurate. It's actually a 575 motherboard, and I wrote that down here in the comments section. This is everything stock, 33 megahertz, 040 with no FPU. All of them, System 7.1, has the same internal hard drive and so on. And then I overclocked to 40 megahertz before I did the VGA mod, so resolution 512 by 384. And then the test that just completed today is the same 40 megahertz clock speed, but with the VGA mod, which means I get 640 by 480 and 256 colors. So as we can see here, my goodness, folks, yeah, even without an FPU, the 040 Mystic 575 motherboard blows away that pathetically slow stock color class. I mean, 10 times faster, folks. Look at that. My VGA mod here. And even though it's pushing more pixels, I would have expected my VGA version to get lower scores than my stock resolution version at the same CPU clock speed, but for some reason it's getting faster performance. But anyway, 10 times faster than the stock Color Classic, and that's why you really do need to upgrade. I would highly recommend you upgrade your stock Color Classics just to make it a usable computer, a fun computer, because why put it behind glass? Why not have some fun with it? And you can only really have fun with it when you have a minimum level of performance, and you just can't get it with the stock Color Classic. I'm sorry. Now, floating point, just another example of that. Again, we have the 68882 FPU here, folks, but take a look. We're getting 0.17. Well, take a look at these scores down here, 0.17. So even though the LC040 does not have an FPU, it's emulating the FPU in software, it gets the same exact score. Now, of course, at 33 megahertz, it's a little bit lower, but still, it's holding its own. Now, later on, I'm going to do a full FPU 040 and show you the scores. That'll just completely blow the floating point numbers that you're seeing here out of the water. But as you can see, the 040 really trounces that stock Color Classic. Next is the disk mix. All of them are using the same internal hard drive, and we're getting not quite twice as fast on the 040 chip. Publishing mix, we're getting more than twice as fast. Scrolling down to the graphics mix, again, I expected that VGA would be slower than the stock 512 by 384, but that's not the case. It's showing a higher score, 5 and 6 times faster than the Color Classic. Same here with publishing mix. This is just a different set of tests that's running, but yeah, 5 and 6 times faster. Now, I would say that you should download these. In the text description below, I have all of these benchmarks for Norton System Info. Everything you're seeing in this video, you can download them. And I would recommend that you do that because you can click this System Info button and you can do comparisons. Like the stock Color Classic compared to the stock LC575. What's the difference in terms of clock speed? Does one have the FPU and not the other? What OS did I run? And then over here on this menu, you can see storage devices, get display info. You can see here that I am indeed running 640 by 480 on this particular one. So please download all of the results so that you can play with this and get answers to a lot of the questions that you'll probably have just from this data in here. And last but not least, I had my camera off and I didn't record the temperature of the CPU. At about 90% of the way done through these tests today, it reached 60 degrees Celsius. So I would recommend that you do put a heatsink on your chip when you run it at 40 megahertz and higher. It's just really, it's not too hot at 60 degrees Celsius, but it is wintertime now and it's probably going to get much hotter in the summer. So having a heatsink on there is pretty important, and I'm going to be showing that a little bit later. So let's see what happens when I overclock to an extremely high frequency. I set it to 700 ohms, which according to the calculator is about 50 megahertz. I still have the LC040 in there, so let's give it a go. Oh, and we can see 24.9, so it's, you know, almost 25. 25 times 2 is 50. Still rock solid 5 volts. Temperature of the CPU is increasing, but I'm guessing I'm not going to get a screen because the VRAM is the stock 80 nanosecond. And I'm not hearing any hard drive access at all, which means that the CPU is not working. If the CPU was working but the VRAM was too slow, then I should be able to hear it boot, but I'm not. So basically, it just doesn't boot. I pulled the motherboard and moved the jumper to the middle pins. I did not change the resistance, but of course moving the jumper will change the resistance. The resistance now is 1.14 kiloohms approximately, which translates to about 45 megahertz on the CPU side. Now I know that's still too fast for this 80 nanosecond VRAM, but let's see if it tries to boot. We can see 22.5 times 2, so we are getting 45 megahertz there. Voltage is rock solid 5. And, oh, I heard that something's trying to power on the screen here. I can hear drive activity. Oh, and we get a screen. I didn't expect it to give us a screen. Wow. Okay, in my other testing, it didn't always come on. A lot of times you'll get a black screen, but let's see what happens here. Well, it's not freezing, but I'm getting what I call pixel dust. So this is truly overclocking the VRAM, 80 nanosecond VRAM too high. And you get a lot of on-screen artifacts when you do this. So this is not usable. You can see all of the things that are going on here, a number of stray pixels. And so this is not usable for this VRAM, but I have faster VRAM that we can try out. Let's first take a quick look at the 80 nanosecond VRAM that came standard with the LC575 motherboard. You can see Apple's markings on the back. And then on the front, we know it's 80 nanoseconds because on the second row at the far right, it says -8, which means 80 nanosecond speed. And here is the turbocharged 60 nanosecond VRAM that will take us to overclocker's heaven. These are also 512K each, the same as my stock VRAM. That allows you to choose up to 16-bit or 32,000 colors. But the key difference from the stock RAM is the speed. 60 nanoseconds is blazing fast. The circuit board was created by Stephen Arsenault of Better Bit. You can see the logo over here. Mr. Fahrenheit used Stephen's Gerber files with permission to create PCBs with his own artwork. He acquired the 60 nanosecond chips from UT Source in China. We know they're 60 nanoseconds because on the third line at the far right, there's a number 6 here. Mr. Fahrenheit kindly sent me 4 of these VRAM sims, and I confirmed in my testing they work fine. Also, Drake has his own artwork version of the same PCB, also 60 nanoseconds, and he sent me 2 pieces of his VRAM. I confirmed that all 3 pairs of VRAM work well and allow higher overclocking speeds. I sent 2 of Mr. Fahrenheit's sims and both of Drake's over to Kay Koba for his own overclocking testing, since Kay has more vintage Macs than I do, and I simply retained this pair. I'm going to put these in the motherboard right now, so let's see what happens with this 60 nanosecond VRAM. Okay, so again, 22.5 times 2, 45 megahertz. Getting a good 5 volts, 4.99. 5 volts there on the 5 volt line. I heard the screen come on. And it is now booting. So here we are booted to the desktop. I'll open up my hard disk and we'll go to benchmarks folder because in here I've got something called Clockometer version 2. You can see a link to this in the text description below. It's showing us our clock speed. This is approximate. The frequency counter is showing the correct half clock speed. This is close though. So you can still use this and get a fairly accurate measurement, but anyway, 45.12 megahertz approximately. And the temperature will cause it to fluctuate over time, and that's why there's a recalculate button here. We can see it's pretty solid on 45.12. Anyway, because we have the 60 nanoseconds very fast VRAM in there, we can see that I'm moving the arrow pointer right now, and there is no pixel dust or pixel artifacts, any kind of pixie dust, if you want to call it, the little pixels that sometimes follow or trail the arrow cursor as you move it if the VRAM is too slow. So this is showing us that this LC040 CPU, which is rated for 33 megahertz, actually does work at 45 megahertz with 60 nanosecond VRAM. And we can see some benchmarks too. So with the Norton System Info benchmark just about 90% of the way through, we can see without a heatsink on it, we're getting about 59.8 degrees Celsius. The room temperature is roughly 17, 18 degrees Celsius, so it is a fairly cool room. But still, it's pretty clear we just hit 60 degrees Celsius. So if you keep running the machine, it'll probably continue to go up higher for this LC040 chip. But it is stable, and we're not seeing any artifacts on the screen. And we see that at our 45 megahertz overclock, the LC040 running at VGA with 256 colors beats a Quadra 650, and it's fast approaching a Quadra 950 with 1-bit video. Now remember, the Quadra 650 has an FPU and the LC040 doesn't, but again, these are the system rating scores, which are the overall graphics, disk, and everything, and that's why even though the FPU tests are pathetic, it's still that much faster in all of the other benchmarks, and that's why it beats a Quadra 650. Now if I scroll down just by one, we can see that at 33 megahertz, it doesn't matter if you're using 60 nanosecond VRAM or 80 nanosecond VRAM, you still get the same score, but the boost from 33 megahertz to 45 megahertz is about 35 or 36%, according to these numbers, a jump from 30.6 to 41.5. And one more thing I will add, that I'm using a disk cache of 128 kilobytes for all of my testing, whether that be in System Info, Mac Bench, Speedometer, because System Info prefers that. So if you're going to do your own testing, I would suggest that you would use 128 kilobytes. And if you're wondering why some of these scores, why is this getting lower and this is higher, I have a full FPU version CPU scores in here as well, and I'll be talking about those later in this video. One of the key disadvantages running at high clock speeds like 45 megahertz is that your serial ports will stop working. I have connected a Newton serial keyboard to this computer, which can be made to work with this and even other computers like the SE30 using a special system extension, which I've linked for you in the text description below. It is connected to the modem port, which is the default port for that extension. Now, of course, the standard keyboard is ADB, so I can still type on it just fine. This is not serial. But if I try to type on my Newton keyboard, nothing happens. And that's because the serial ports don't work at 45 megahertz. I pulled the motherboard and changed the jumper to the far left, and that changes the frequency to 20.277, which multiplied by 2 is 40.55 megahertz. That's low enough for the serial ports to work, and we can prove that simply by typing on my Newton keyboard. It works fine. I can overclock to about 43.48 megahertz and it will still work. But the serial ports stopped working when I overclocked to 43.7 megahertz. So you need to remember that when you're overclocking, do you need your serial ports or not? Chances are you don't, but it is an important consideration that may limit to how far you can overclock. Friends, I need to make an abrupt stop here and be very serious with you on a matter that a major family medical emergency transpired over the last few days. In fact, during the filming of this closing segment, I just got a call and got off the phone with the hospital. And it has consumed my every waking hour. I literally have no time. So I made the decision to break this video into two parts. I normally don't like to do that because for me personally, whenever I watch part 1, part 2, part 3, it kind of breaks up my train of thought. And I believe that's probably true for some of you too, so I'm really sorry about it. But I just am unable to do it right now. So I would like to promise you though that that part of the video is coming. That's going to cover the full FPU version, heat sinks, heatsink fan, and some amazing performance. I mean, truly the best is yet to come. But as to the timing of when that's going to come out, I'm really sorry, I cannot say right now. So I'd appreciate your understanding about that. Before I close though, I would like to thank 6 really amazing people who contributed to this channel by PayPal in the month of February 2022. The first is anonymous donor number 1. He's anonymous because I always try to get permission from people to publicly mention their name whenever anyone donates, and I was unable to get a reply back from him, but you know who you are. Thank you very much for your donation. I'd also like to thank anonymous donor number 2. This gentleman asked specifically to be anonymous, and I'm going to, of course, respect that. He's really amazing because this is actually his second very generous donation since December of 2021, and you know who you are. You're a really amazing person. Thank you. Thank you very much. Next, I would like to thank JCS from Chicago. Next, Joe Williams. Joe has also made a second contribution, his first being in November of last year. So thank you very much, Joe, for liking this channel so much. Next, a name that everybody knows if you've been watching my other videos is Mauro Acciaccaferri. He's a monthly supporter of this channel. Thank you very much, Mauro. I appreciate it. And lastly, I'd like to thank Stuart Ramdeen for his contribution as well. Gentlemen, from the bottom of my heart, I really appreciate your generosity to this channel. And it will definitely go towards making more vintage Mac content like this. If you got something from this video, even though it's not complete, and if you'll please forgive me for breaking it into 2 parts, I'd certainly appreciate it if you give it a thumbs up. Please subscribe and click the bell icon if you'd like to receive notifications of whenever I come out with a new video. I do promise that I am going to work on that part 2 video, and it's going to be something worth watching. I just can't say when it's going to be at this time. But thank you very much for watching today, folks, and I truly wish you a wonderful day. Take care.